Problem number 2. Sarah's teacher suggested 8 different novels for her to read this semester for extra credit. If Sarah picks 3 novels, how many different sets of 3 novels could she choose? So this is a pretty classic combinations problem. Now, if you don't know combinations, you'll have to figure out a different way to do it. But if you know combinations, let me show you that first. So what we do is basically say, okay, we got 8 things. We want to choose 3 of them. And the question then is, does order matter or not matter? And we're told that there's, how many sets of novels. Usually the word term sets is a key as to whether order matters or doesn't matter. And so in a set, order doesn't really matter. So here we have 8 things. Let me write this out. This combination. We have 8 things, and we want to choose 3 of them. And order doesn't matter. That makes it a combination. Otherwise, it would be a permutation. And or we could write that as 8 choose 3. Okay, that's another way of writing it. And that's just 8 times 7 times 6 all over 3 times 2 times 1. And, okay, so we have 3 times 2 times 1, that's 6. And I'm going to cancel it with this 6. So we end up with 56. And that's the quick way to get the solution. Alright? I didn't give you a hint on this one. I just launched right into the solution, so sorry about that. But if you don't know combinations, let me give you a short lesson here in combinations. Okay? So the way that when you're learning permutations and combinations, the first way to think of it is as a tree. So let's say we have 8 novels, and I'm just going to call them A, B, C, D, E, F, G, and H. I think that's 8, right? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have 8 novels. Okay, and so here's Sarah, and for her first novel she has 8 choices. Okay, so she's got to pick A, B, C, D, E, F, or G. Okay, or H. So she essentially has 8 choices for her first novel. Okay, and so I'll just draw 8 little lines from Sarah. So those are her 8 choices. But once she's picked 2, I'm gonna write 1 up here. Once she's picked one novel, she has 1 less novel to choose from. So for her next choice, for choice number 2, now I'm not going to write all these out because it gets really messy. But so then she only has 7 choices for her second novel. So if she picked A, then she's only going to have B through H to choose from. Okay? And if she picked B, then she's going to have A and then C, D, all the way up to H. Okay? So you can see that, okay, she has 8 choices for the first. She has 7 for the next choice. Okay? And then she's going to have 7 choices for each of these 8 choices. Okay? So on her first choice, if she picked F, then she's going to have 7 choices, all of the novels except for F, to choose for her second novel. Okay? So essentially, we could, to figure out, for the first 2 novels, we can just take 7 times 8 to get the total number of ways that she could choose the first 2 novels. Okay, because each one of, once she picks the first one, each one of these choices for her first novel is going to have 7 choices for the second novel. Okay, so we'd have 7 branches here, 7 branches off here, 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 and here. So that's 7 times 8. Okay, and then, okay, it gets really messy. If she chose B for her second novel, then she would have C through H for her choices for the third novel. Okay, so now we have 6 choices for the third novel. All right, and so that's actually a permutation. But if order doesn't matter, then we have to look at how many duplicates we have. So for example, if she chooses novel A, B, and C for her her set of 3 novels, you can see there's an A, B, C path here, but there's also going to be a BAC path here, and there's going to be a CBA path here from C. So, but really that's the same set. So ABC is the same as ACB, which is the same as BCA, which is the same as BAC, which is the same as CAB and CBA. Okay, so in a permutation, order matters. Okay, and when you do a permutation, each one of these sets of novels are going to be different. Okay, they're going to be counted as different choices. But in reality, it doesn't it doesn't matter the order she picks these novels in. It only matters what the set of novels is. So really, all of these are the same. So we've overcounted when we've done a permutation, and the question then is, how much have we overcounted by? And you could see that for any 3 novels that she chooses, like for example, if she chooses A, B, C as her set of novels, she's going to have 6 ways to arrange those novels. Okay, so essentially we can compute the permutation of the number of ways to arrange 3 novels is just going to be 3 times 2 times 1, because when she takes this set of 3, she would have, and if she was going to arrange them, she had 3 choices for the first novel in the arrangement, 2 for the second, and 2 for the second and 1 for the third. So this is another permutation actually. So we've overcounted essentially by the permutation of 3 novels. So, and that's essentially what a combination is. It is just the permutation 8 times 7 times 6. Okay, it's the permutation of all the different novels, or sorry, the permutation of 3 novels taken from 8, all right, which assumes that order matters, and it's divided by the number of ways that we can arrange the 3 novels if order matters, okay, because we've overcounted by the number of ways to arrange the 3 novels, okay, so 3 times 2 times 1. Excuse me. So that's a quick, very quick lesson in combinations, okay. It's basically 2 permutations. We've taken the number of ways to choose 3 novels if order matters, and divided it by the number of ways to arrange the 3 novels in order to correct for the overcounting in the permutation. Alright, so again, 3 times 2 times 1 is 6, so it's just 56. Alright, so there you go. That's how you do that problem.